What's up, goobers? Yeah. Today, we're gonna be taking the we're gonna be taking the MACROPAD, version 2 that I started prototyping, last stream, and, we're going to turn it into a PCB. We're gonna make some, schematics in KiCad, and then, we're going to be turning it into a PCB layout, based off the stuff that we got working, last stream. So, yeah, let me go switch over to the webcam view. Here. Okay, so, on the workbench, you can actually see, two projects going on. First one is the hydration thingy. It still needs a name, but, if you type in !hydrate, into the chat, then it will dispense some water that I will have to drink. So let me do a demo of that real quick. Hydrate. Come on. Okay, there. It switched over. Yeah, it actually responds like so fast that my camera transition can't even keep up with it. But yeah, if you type in !hydrate, then you can make me drink water. I will go drink some water. And then we have this second project here, and this is what we're focusing on today. So this is like super duper simple right now, but this is a Raspberry Pi Pico 2W microcontroller. It has Wi-Fi, and we are simulating a single button on this thing, and we have LEDs outputting the status of it, and we have a relay so that we can control external circuits, and yeah, so ideally, let me go plug this into power. Ideally, when I press that button, it should set my lights in my office to purple, and hopefully nothing got unplugged while I had this in storage. It's possible it doesn't work because it was unplugged. Okay, so we have two lights on. I forgot what that means. Let me go open the source code for that. What does two lights mean? Show the screen. Okay, Sea Lion. We are in the source code. And, RGB LEDs. Says that we have 11 LEDs here. And if we're connected to Wi-Fi, then, that should be blue, and then that will be blue. Okay, I think that all white means that we are ready. Yeah, all white means that we're connected to the network. So that should mean that whenever I press the button, the lights in the office should turn purple. And so let me set them all to like super duper bright white, just so that we could demonstrate that. And then if we press this button, we're sending a command, and the lights in my office have turned purple. So, yeah, that demonstrates that it works. And so instead of a single button, what we want is, actually let me go unplug my thingy and put it on the desk so that y'all can see what we're basing this off of. Because I have like a MACROPAD that has like 12 of these buttons, and it's usually attached to the bottom right corner of my desk. So let me go move that over here, just as another kind of reference of what we're working on. And let's power it up also. So that's micro USB adapter. Should really just glue it into this. That is one thing that is going to annoy me in this project, though, is that we are using the Raspberry Pi Pico 2W, yet even though it came out, I think, last year or 2 years ago, it still uses a USB micro instead of USB-C. But yeah, hopefully... Ooh. I'm not sure if my phone was in front of all that. Oops. Let me turn the ring light off. Okay, so yeah, you can see that this is what the V1 of this is. This was never actually a proper PCB. This was like 3D printed and stuff. I have a previous stream where I did a complete teardown of it. I don't want to take it apart right now for the stream, but yeah, this never used any real PCB. It was like a bunch of stuff 3D printed, and then I hand wired all the stuff to different leads because I didn't know PCB design at the time. But that's why I'm making a V2 of this, so that it can be a nice, clean PCB and easy to manufacture. And yeah, so if we turn this light on, that will set my front center light in my office to warm light. If we press this light, then all of the lights in my office, including the overhead light on the workbench, are bright white. If you press this light, all the lights should turn off. If we press this light, then the light should be purple. And maybe just to match the mood of this, I will also set my lights to purple. Yeah, okay, cool. Yeah, we have matching lights between IRL and virtual, so that's cool. But yeah, so I guess the goal of today's stream is we're going to be taking the design that I made with only a single button. Shit. Hold on, this is kind of awkward. The MACROPAD is actually used to make my desk go up and down, because I have like a sit-stand desk. So I guess I need to figure out if I want to commit to sitting or standing. I think I want to sit this stream. Yeah. But that means I have to unplug this and connect it real quick, and then move my desk, and then put it back in place. Wait, hold on a second. I'm hearing something weird. Let me go check it out real quick. Okay, I'm back. Nothing's on fire. Yeah, let me go lower the desk. And then... Okay, that should be good. And then let's plug in the MACROPAD because it's nice and shiny. Shit, where's a cable? Oh, this actually works. Dropping down from the ceiling, since my iPad doesn't have to be up there right now. Okay, cool. Alright. So, yeah. Let me get the iPad that I just mentioned out, and we'll do a bit of whiteboarding right now for what we want to do today. Okay, iPad. And OpenAir server, which has been really clutch for this. I bought like a whole whiteboard and a bunch of markers, and it turns out that just projecting the iPad out is so much better than that. Okay. Let me see, did I take any notes in some other thing? I did, okay. So let's mirror the screen. Alright, screen is mirroring. Hide that screen. Okay, cool. And why is this thing floating up here? Oh, that was the 3D print view from last time. We don't need that right now. Okay, so PCB MacroPad V2 Part 2. Today we are going to is design the right word for it? We'll just say do the schematic. Make the schematic, yeah. And so the schematic is just basically going to be the circuit diagram for this project. And then we need to make the PCB layout. And before the stream, I checked out KiCad to make sure that I have the right libraries and the right footprints and symbols, which I'll talk about what those are, but we are missing a couple, but the good thing is that we can make them live on stream. So the two missing ones are going to be the, I guess maybe 3, possibly. No, wait. Okay, actually, I forgot about the LEDs. I'll have to check those, but, I guess those will be, like, questions. So I know for sure that I need to make a, Raspberry Pi Pico 2W symbol, and need to make the relay footprint. And it's probably gonna be in there, but I'll need to check. NeoPixel symbol and NeoPixel footprint. But yeah, this stream's gonna be pretty much almost entirely on, the stream is pretty much gonna be almost entirely on the computer, not really gonna be doing much workbench stuff, other than, like, referencing stuff and, like, I guess, taking measurements and such. But yeah. Alright, so, yeah, let's show the screen again, and we don't need the iPad view right now. Alright, so this is the firmware from last stream. Don't really need to do much with that right now. We're gonna go to KiCad, and the first thing we're gonna do is we're gonna make the schematic. And so, like I said before, this is the circuit diagram, basically, and when I was talking about the symbols before, those are basically all the little parts of the circuit. Sometimes it's gonna be, like, really simple stuff, like just resistors, capacitors, etc. Other times it's gonna be, like, entire complicated, I guess the equivalent of assemblies, but, like, for circuits. So that could be, like, an entire Raspberry Pi Pico 2W dev board. And so, why did I pick the Pi 2W dev board? I actually took the notes of it. Actually, yeah, we can get a air server. Go back to the iPad, because I took notes on why we're doing that. Okay, so we wanted something that, that had enough pins to, drive, all 12 buttons and some more for the relays. We wanted it to have Wi-Fi because it's an IoT thingy. Bluetooth's a bonus. I don't know what we're actually going to use that for, but why not? And USB HID so that it can be used as, like, a key, like, basically for key input, or for some reason maybe gamepad or, like, MIDI instrument. Yeah, just wanted to be flexible. So, yeah, that's a thingy. And, yeah, the Pi Pico 2 is cheap, it's common, and it fulfills all of those, so we're gonna use it. But yeah. So, speaking of that, we actually have to make the custom footprint for that real quick. So, was it? No, sorry, the symbol. So, let's make a new symbol. Or, I guess let's make a new symbol library. Add library to global, sure. Pi Pico. Oh. Hold on, can we make a new library from this? Okay, so I think I selected, like, select a library instead of make a new one. Okay, new symbol. Let's call it... Let's read Pi Pico 2W. Yeah, sounds about right. Yeah, let's make its designator, I know, RPI. And, you find, oh, that's actually perfect. Pi Pico 2W pinout. Something that I did check before is that the Pi Pico 2W has the exact same pinouts as the not Wi-Fi version of the old Pi Picos. So yeah. Oh, there's a USB-C version of this. Ooh, that's good. Okay, I have to look into buying that one instead of one of the generic ones. But yeah, we'll just find a clean, compact pinout. And then we can just split screen this. Yeah, that should work. Okay, yeah. Actually might be easier just to start off with, like, 2x20. And just see if there's one that matches that. 1, 2, 3, 4, da 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 da. Okay, that's weird. Not you. Okay, yeah, that one should work. Yeah, let's actually just base it off of this. This should be... Yeah, those pins are lining up. So, let's save a copy of that, actually, into the Pi Pico thingy. Pi Pico. And can we rename that? Yeah, we can. RPI Pi Pico 2W. Let's overwrite it. Okay, there's actually two of these. That's not great. Let's actually just close it out and reopen it and see if it merges back into a single one. Okay. Is there like a dark mode for this? Oh, it disappeared. That's not good. Okay, well, yeah, let's just resave that in there. And then I guess mess with it or something. Okay. So Pi Pico, rename you to RPI Pico 2W. Oh, and then hit save. I just forgot to hit save. And then let's just sanity check one more time and make sure that actually shows up. Where are you? Pi Pico? Yeah, it's there. Okay, and so I just want to stretch this out. For some reason, my iPad was talking to me. But yeah, let's just stretch that out. And let's just get all the power pins here, I guess. want to do this? Maybe, can I just name it something? Because I'm not too familiar with the with footprint naming stuff, I guess. Each. This will also be ground. 13 is also ground. 18 is also ground. 33 is ground. 28 is ground. And 23 is ground. V-bus. V-sus. Did I rename you? No, I didn't. You're also ground. 3v3. Oh, that's E, not 3. 3v3. This is 3v3. Okay, I don't know if those actually have to be changed to something that's not, like, passive. Because I'm not sure if, like, ground is going to be, like, power output also or something. But, okay, I don't think we need to, like, think about that too hard. And then I guess I'm just going to put these, like, pin names as text inside of the thing. So with that, it's going to drag that over here. Okay. So let's just call this GP. Yeah, that works. And then I'll just copy that. And then we'll just tweak it as we need to. Actually, that just does not look that neat. And this is faster if we just clone them like that. Yeah. And then let's highlight these. And let's right justify those. Wait, is right the correct one? Yeah, right is the correct one. And then let's left justify these. Not you, not you. 21 things selected. I don't know what's selected there. Okay, whatever. Left justify that. And just move that over. Okay, let's save. So that's GP1. Ground. GP2. GP3. 6 is GP4. 7 is GP5. 8 is ground. Wait, 9 is GP6. 7, 8, 9, ground. 10, 11, 12, 13, ground, 14, 15, 16, 17, ground, 18, 19, 20, 21, ground, 22. I don't know what run is, but okay. Huh. I know where 23 through 25 are, but oh no, that's 26. '27 ground, 28. I don't know what that is. It's just like a long dash line there. So I'll go look at another pinout and see what that is. Bus. Alright, and so Pi Pico pin out. What is that funny thing? ADC VREF. Okay. Okay, cool. So we have that symbol, and yeah, that works now. So should be able to pop that in to that. There we go. And yeah. Okay, so we're not going to connect anything yet. Let's see if WS2012B. Yeah. Okay, cool. So the WS2812B, that's the RGB LEDs, and we're gonna want at least 12 of them. Maybe have another one for like status. But yeah, let's do that. And let's move this around so it's not in the way. And you can also just copy some like grounded stuff. So ground goes there. And let's have 5 volts. Oh, that typed 4. Oh no, we want power symbol. I have to look into if there is a 3-volt version of the 2812, because then we can just tap it directly off of there. But for now, that should work. But yeah, we're gonna want. Wait, are those actually connected? Yeah, they are. Okay, cool. 4, 5. Or no, that's 7. Okay. 8, 9, 10, 11, 12, and then maybe want, like, you could probably have, like, 2 more for just, like, status. Oh no. Actually, I just used the overall, just the state of all of them for status. That's probably cleaner. So, yeah, let's just do that. And then, so each of these corresponds to a key, and we're gonna have 12 keys. And then, we're gonna have the switches. These are just like a super duper simple switch, just a generic switch. What if I type in cherry? MX. Is it just like a super generic switch? Oh, single pole, single throw probably. Yeah, that'll work for each key. Alright, so one of these is going to go to one of the pins, and the other is going to go to ground, I think. Yeah, because we want it to be pulled down, I think. Let me just confirm in the code what mode it's on. Okay, so setup, input, pull up. That means that it's going to be 3.3 volts, and we want to connect it down to ground whenever you trigger it. And I also just want to confirm that Alexa, set workbench light to white. Alexa, set workbench light to white. Or Alexa, turn workbench light on. There we go. Okay, yeah, so if we look here, when I prototyped it, this is connected to ground, and when this is not pressed, that is open, and then this goes to this pin, and so normally, because it's set to pull up, it's pulled up to 3.3 volts, but with like a really, really chonky resistor. So as soon as we close it, then that has no resistance, which means that it's pulled down all the way to ground without like any real fighting there, and that means it's on. So we want to replicate that, and I think there's something about how the Pi Picos pull down is like either crappy or non-existent, but it has pull up built in, and if we can reduce the amount of parts, then that's great. And so, because I think I want to have it so that, like, all the key switches are on that side, and then the relays are going to be on the other side, yeah, that probably makes sense to me. We'll just have all the key switches up here. And I just want to copy pasta all of that, so put some ground here. And we're going to have 12 switches. Run into that. Yeah. Doesn't need to be neat. We can just have it in 2 rows and just do that. And I was also planning to have 4 relays out so that we can control up to 4 external connections. So, when we want to do that, let's see what the relay symbol is. This is, quite a bit. Let me see if there's one that looks like the footprint of the, relays that I found. I That's really close, but that's not exactly it. Okay, that looks really close to it. Which one's normally O's and which one's normally open? Okay, so normally open, it's not touching, normally closed, it is touching. So I think we want that one. And we'll see if that's the exact size that we want. Oh, wait. Huh, that's weird. Its pins are 1, 3, 5, 7. Okay, so let me just confirm on here, because the outer two and the inner two. Okay, so the inner two here are controlled. That is what we want to control, or that is the input to control the relay, and then the outer two controls the external stuff. And so inner two, I guess that's electromagnet or something, and the outer two are the switch. So that's what we want. So that should work, and we can just change the footprint if it's not the correct size. But we can also shop for other footprints too. Although, interesting. I'll just go back to the one that we found, because that should work. Okay, so let's just rotate that so that we can have like all the external stuff on the left. And let's just plop like 4 of those down. Oh wait, we should probably add the power connections also. Okay, so going back to here, how do we do it? Control, okay, so, yeah, one just goes to ground, and then the other one just goes to, like, an output pin. Yeah. Although, I'm not sure if it actually matters which side. Well, no, it's not going to matter because we can just rotate it. Ew, that's kind of squished. I'll just move those. Okay. Yeah, that should work. And then we'll just move this one. Let's just actually count the spaces. Okay. So let's go from the point of touching that. Okay. 1, 2, 3, 4, 5, 6. Yeah, that's enough room. 0, 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4, 5, 6. Okay, cool. So you have that. And honestly, this is a pretty simple thing. We don't really need to go too crazy on it. Because, like, this stuff here, we don't need this LED. This is really just to test out if this relay is working. And so, yeah, you don't really need too much going on here. Okay. And we have a ton of pins out here, and we do not need to even worry about, like, matrixing them or multiplexing them, so we can just directly route it to different things. Yeah, so let's save that. I know that people like to have a thing where it's like, we just have this, and then we just have it, like, kind of teleport here, but for some reason, I just personally like to, draw out the connections. But let me go reorganize this so that, I guess also want to, what did I want to do here? Connector 1 by 2. Yeah, it doesn't matter which one really. As long as like one of these. Yeah, we want to have these correspond to the relay outs. Let's have it line up with that line. Where did... Oh, okay, so that's J1. Yeah. Okay, cool. So let's connect that to there. And so we're actually doing the routing. So the output of the relays is definitely supposed to go out to whatever external devices that we have. And then what pin did I use for oh no, that's the wrong one. What pin did I use for RGB LED? D14. And I just like using pins that like are guaranteed to be the correct ones. It might be a smart thing for me to do maybe off stream, just like I guess check what the pin outs are, or let me rephrase that, to check that the pins I've selected will function properly. But, I mean, nothing here is doing like any analog stuff. Everything's gonna be digital in and out, so I can't see why we... The only thing that's kind of weird is, I think the 2812s can be a little picky. But yeah. I mean, GPIO is general purpose. And I don't see why we couldn't make that just do normal digital out, digital in, so, yeah. Alright. So, I guess, let's just route these, then. And then, do we have 12 outputs on this side that we can just directly route to also? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10... We don't. We're gonna have to route some of those out somewhere funny. Two... Okay, yeah. Is this... No, that's nasty. That should not go to ground. That should go to a thingy. I'm gonna have to move those lines around a little. Okay. $15. And then this one's gonna just kind of skip to 13. Cool. And honestly, that should... Oh, I guess... Need 5 volts to come from somewhere. Let me see... Where's the multimeter? Let's see how much voltage comes out of there. I mean, it should just be 5 volts. If it is just 5 volts, then let's just power it off of that V-out pin. Oh, and plug that. Oops. So that's B-bus. And... okay, so you're powered on right now. And you should be ground. 5 volts, that'll work for us. Oh, why did I unplug that? That didn't make sense. Alright. So let's add 5 volts. Okay. And let's also just connect all the grounds together. Oh, that's a good thing. Yeah. Don't want that going there. It's a really good thing I made sure to check that. Just make sure all of the grounds don't have something connected to them. Okay, cool. You should be good there. Two and 3. Okay, and then connect those. This probably isn't the best practice, but I'm not a professional at this yet, so I'll figure that out later. And ground here, and then let's add not connected, not connected, not connected, not connected, not connected. Okay, cool. That should work, I think. And you're not connected. Yeah, I think that works. Okay, I'm gonna go take a pee break real quick. Let me fix my trackers, because they all turned off when I left the room. Okay, whoa. It's wacky. Okay, back to normal. Alright, so, I actually don't want to sit in this chair anymore. I want to sit in my other chair. Normally I use, like, a kneeling chair for, like, because it doesn't obscure the back, so I can use a hip tracker. But, I'm actually just gonna disable the hip tracker. So, taking my hip tracker off, going to the, config menu for the tracker. Actually, let me just show the UI, because the UI is fun. Oh, we're not in iPhone only mode. I still need to fix that bug. But waist is disabled. And now the waist tracking is inferred by my head position, plus also angle. But yeah, I want to sit in my nice steel case instead of this kneeling chair. Yeah, that should work. Cool. Okay. What were we doing? I guess I made the schematic. And now we can just, do DRC check, I guess? Where's that? Here. 2 errors. Input power pin not driven by any output power pin. I guess that is all of those. Wait, what? Why is that? Oh, okay, so this is a super easy one to fix. There's just like a stray, not connected thing. Okay, let's try again. So these are not happy. I guess we can just set those in the footprint as power pins, I guess. Let's edit the symbol and make those power pins, I guess. Power output, I guess. Should ground be a power output? I don't know. I know I should set all the other voltage ones to that, but I'm lazy. And we're not going to use those. Is this going to fix it? Okay. That makes it happy. Yeah. I don't know what you are, though. Oh, okay. It's because the symbol has been... You know, let's actually do it correctly. Although I do want to know if setting multiple grounds that are connected together as power output is nasty or not. Let's save that. And let's just reset those. Okay. And let's see if the DRC still is happy. Oh, power output and power output are connected. Okay, it's not happy about that. Yeah, I need to figure out what these power output things are supposed to actually mean. But, let's just make all those passive, I guess. And we can do it the proper way a bit later when I learn how to do that. But yeah, we'll just keep it simple. Power output here. Okay. Update from library. And then let's run the DRC check. Okay, cool. That works. Everything looks like it should work, I think. All of these are the same thing. Ground is connected to there, and yeah. Actually, let me just confirm VDD versus VSS. Okay, so yeah, SS is ground and DD is power. Yeah. Cool. Okay, so let's assign the footprints. So the footprints are basically going to be like the... Oh, I forgot to change back to, what's it called? Forgot to change back to, the computer view. Okay, there we are. Yeah, so this is the schematic that we have right now, and, I was messing with the power, output stuff just to make the, DRC check happy, and it is happy right now. Which means that everything's connected and nothing seems to be a blatant violation. So yeah, we can now assign the footprints. That's basically just like saying what component the things are. And so here, connectors, let's just do a JST XH. JST XH, let's make it horizontal. What are the difference between these two? I thought that there's like a way to preview these. I guess it's right click select. Yeah, that looks right to me. What's the difference between these two? They look basically the same. Okay. So here, let's Pi Pico. Okay, so I want to normally do that, but yeah, let's do solder mount or surface mount, and then these are already a pretty standard size, and we don't need like the super tiny ones. Then here, let's just for the switches, we're just doing Cherry MX form factor. And I forgot which one has the holes and which one doesn't. Okay, we want the one with the holes. Okay, cool. So we've selected all the components. We're using Cherry MX form factor switches here. We're using just the normal WS2812B here. And I don't know why my hair is going crazy on the mocap, but whatever. And we're just using a normal, cheap, what's it called? JST XH 2-pin connectors here. So I think we're actually ready to make the schematic now. Or not the schematic, the layout. So this is where we actually lay stuff out physically, and put traces and stuff. So let's update the PCB from the schematic. Close that. And then we can just lay these components out. I'm gonna move these out the way, and we're just gonna be concerned with this stuff. I really hope there's not gonna be like an annoying exclusion zone thing with well, actually first we should probably measure the relay and make sure that this matches up to our actual relays. Although we could also switch out the components, because really through-hole relays, that was working well just for prototyping, but we don't necessarily need to use that for the final production version. But anyway, let's go lay these out. Why is my mocap going nuts? Yeah. First off, I want to figure out if... Does this tell me what the length of that is? I guess maybe just check out the footprint itself, if that's gonna be, so that's 19.05 millimeters. What does that convert to in inches? 19.052 inches. Okay, so we want to work with inch units, not millimeter units here, because, where am I? I'm lost. Yeah, let's work with, inch units, because keyboards are made in inches, not in millimeters. So where's that? Where do we edit the units? You know, maybe my mocap stuff doesn't like not using the, those trackers. Well, you know, actually, let me disable the, feet trackers also, and maybe that'll stabilize the, here. No, that's not working either. What if we just, like, disable everything except, the head tracker? Test, test, test. Yeah, I guess that's working. Okay, cool. Alright. Where are... Why is my mocap going, like, fucking crazy today? Okay. KiCad set units inches. How do I do that? Oh. Oh, it's actually here. Okay, that's easy. I seriously have no idea why my mocap's going nuts. But anyway. Okay, let's just restart that program. Alright, Pro Graphics, reopen. So you get avatar mode. Hopefully you're more stable now. I don't know what's going on. That was weird. Oh my gosh. You know, it doesn't matter. If I stand up, it's not as bad. Although, is my Wi-Fi on the wrong Wi-Fi network? It is. I don't know why it keeps switching to the slower Wi-Fi. Okay, let's go back to the face capture. Test 1, 2, 3. Test 1, 2, 3. Okay, now we don't have latency. Screw it. I'll just go back to the chair. Okay. Let's do this now. What's the best way to line this up? I guess just by that. You can have a little bit of spacing, I guess, here. But oh no, this is not set to. Oh, okay, so that's gonna be millimeters based, and that's gonna be inches based. Okay, cool. Okay, now this is gonna be cleaner to do. Okay, cool, yeah, that is lining up perfectly. 5. Ah, heck. There we go. 6. 7, 8, 9, 10. Very picky with where you click on that. Okay, there. And then this is actually the part that I'm not really sure what to do, because it'll start throwing a fit if stuff is, like, overlapping. Oh. Yeah. And are those... Is that even the right... WS2812 size, keyboard? Can you use the full-size RGB LEDs on a keyboard? Okay, let me just look up keyboard PCB with RGB and see what size that they're using. Okay, that looks a lot smaller than 5 millimeters. Yeah, I think we actually have to pick a smaller one. Because... Let me just zoom into this picture. Okay, so the width of the LED is about the radius of the hole. Of the big hole. And so I have key switches next to me, and we can go to the workbench and we can measure that. Okay, that's zeroed out. And yeah, so that's 3.75 millimeters instead of 5 millimeters. And I wonder if there's a footprint that includes both of those. And then we might have to reorganize some stuff a little bit in the schematic. So let's see what's going on here. Footprint editor. Cherry. What about MX? Okay, let's see if there's like a combined RGB LED footprint KiCad. Let's see what's in here. Replaced by that guy. LED MX. Interesting. Okay, so there are footprints that have the RGB LEDs built in. Okay. let's download it and put it in then. Okay, that looks like it's the latest one. Let me just hide the screen, because I don't like showing it when I'm messing with files. Whoop. Okay. Still messing with files right now. Messing with files, messing with files. Okay, so KiCad. I guess I can just copy pasta that entire thing in here. Copy pasta, copy pasta, copy pasta. Alright, hopefully that doesn't break everything. Oh heck, I may have done that a little bit wrong, maybe? Okay, I think I messed that up. Okay, I didn't mess it up there. Resources, 3D models. Symbols. Did it not copy the symbols correctly? Oh, you know, I think I'm actually looking in the wrong folder. Okay. Preferences, symbol libraries. Unless, does this have like an automatic search for symbols thing? Oh, okay. I can actually add multiple symbols at once. Okay, cool. Alright, and I'll share the screen again. Oh no. Okay, I need KiCad 9. Okay, let's upgrade that first. KiCad. Oh, come on, you tell me to update, and then when I actually want to update, it doesn't actually update. Okay, KiCad installer. Windows, America. Okay, why has Siri been listening the whole time on my iPad? That's weird. Okay, let's install KiCad. turn the arm tracking back on. Yeah, I know I was like freaking out when I was sitting in that chair, but whatever. Okay. Arm tracking, come on. I guess it doesn't want to arm track, that's okay. It's not important. KiCad 9. Yeah, let's just import settings. Alright, now let's look at the, all that. And where are those? Let's add these guys. Okay, that's happy enough. And then let's add... Was that symbols that we already added? Oh, it could be at the bottom. Yeah, it's at the bottom. Okay. And then footprints. Let's add... Where do we put that? Footprints. They'd be like, feet. Okay. That will probably work. But, yeah. Probably have to redo the key switches and RGB LEDs, but that's not too bad. Alright. Let's see. Cherry MX with RGB LEDs. I don't need that. That is a weird symbol. I'm not sure if this is what we want. Okay, we'll just go through all of these and see what's up. It's not happy. Maybe we just want to replace the footprints of the RGB LEDs, but not everything else. Let's make it the super tiny ones. Yeah. Okay, I guess we don't have to change our schematic then, we just have to change the PCB. Because I thought that would have, like, combined footprints. I have to look into this later, but... I think the move is to just... just use these tiny guys here. If we can figure out how to actually move it around. I'll have to check if that's like even an appropriate placement, but okay. out for RGB. Yeah, it does. So, yeah, as long as it's not like... there, and then we can just like move this around, and I'm in a keyboard designer's Discord server, so I can consult them to make sure that this is correct, but for now the rough placements should be okay. I wonder if there's like a keyboard shortcut or something so that like we can just get the center of whatever we selected. Not on center. Okay, there. This is actually kind of really large, like larger than I expected it to be. But I guess we can just consolidate all of the connectors to be at the top. For like weird stuff. Okay, let's just recenter all this. And then where do you want the outputs of these to be? Especially in relation to having these, like, relays. Honestly, these relays are kind of slim. So, like... they don't have to be, like, right up... ah. How do I get it to, like, select the center of this? Because it doesn't want to select it neatly. Well, at least that lined up. Why are you not going in the center? Okay, that's lined up. Close enough. I do like to group all of the ports as close as possible to each other, though. And, you know, this could actually just stack here-ish. And then we just need to, like, make all the wires kind of go together and make, like, a nice little PCB thingy that squishes together like this, I guess. Okay. So... where's the cutting? Cut. Edge cuts. Just, like, hide all of that for now. It's a lot of clutter. Margin and courtyard. We don't care about the courtyard there, to be honest, because we're gonna have to, like, overlap those, we're gonna have to overlap those, LEDs anyway. Where's edge cuts? Okay, cool. Wait, that's weird. Why is that a thing? Oh, I see. Never mind. Okay. So, edge cuts is here, I guess. Well, we also want some, like, holes to mount stuff, I guess. round out those corners. And then we can delete this rectangle and just replace it with these things. It's just lines. Okay. And I wonder how that's going to look like on the 3D view. That looks reasonable. It'd be nice to have a 3D model for the key switches and diodes and stuff, but yeah. Okay. I want a 4-layer board. Cool. We have 4 layers now. And then, I forgot, what was the, 4-layer PCB? Okay, well, no, I don't trust the AI summary. Okay, so outer layers are going to be routing, inner are going to be power and ground shields, or ground planes. And the ground plane will also be a shieldy thingy. Ground top, power bottom. Yeah, sure, let's just do that. Okay, so inner one, let's make a ground plane. Okay, so ground plane, and then here, let's do a power plane. Okay, cool. So that means we can use top and bottom for routing, I guess. Predefined widths. and I'm a little hungry, so I am munching on a Costco nut bar. Just finding some webs. Okay. So what does this look like? Hold on 2 seconds. I can do that. But yeah, I want to add some connections. Yummy. So then we'll just connect all the grounds to the ground plane. And, okay. Unconnected items is good so far. And then we can also connect this guy so that we actually have power going through everything. And we'll just add a bunch of these, and then also have it go kind of backwards to there, and just add more of those, just to make sure that's like nice and connecty. So go from 74 to 77. How did more things get unhappy? No, is it just silkscreen overlap? No, that's just a warning though. That's not an error. Oh. Those vias are too close together. Guess we can spread them out then. Okay. $77, $74 now. Unconnected is 62. Okay. Well, it looks like that anything that's like 5 volt actually just needs to be can I just like put a pad on the edge of those? Oh, I see. Okay. That's a new feature, I think. I don't think I remember KiCad letting me do that, which is just select the nut that a via should be on if you just kind of place it blindly. But I'm not complaining. That's good development. And then we're else we need that to get around. So slightly in the upper half of that. Okay, this is pretty repetitive. I wonder if there's a way to like just kind of like mass combine some like footprints and stuff. Might be convenient. Yeah, let's go link those. First half is good. Okay. So we have that. And now I guess we can connect these. It'll be a little wacky looking, but kind of cool looking too. It's almost like ocean waves, yes. Does that go anywhere? Nah, it doesn't go anywhere. Okay, cool. So then there's this one last guy here. And we can probably move that up a bit-ish. Yeah. Okay, let's see what DRC says. Unconnected 28. That's quite a bit. Or quite a bit that we've eliminated, which is great. So what does that mean? We'll just connect all these ones up now. I wonder if we could actually just do all of this on this one layer. That'd be funny. Squeeze by ya a little bit. Okay. I guess here we're gonna have to go backwards. Not backwards, but I guess. Yeah, that'll work there. Okay, there's an exclusion zone there, that's why it's acting funny. And then from here to here, and then we just need to connect those guys up. Oh, rip. This one's in the way, but we can just move it here, and we can just move this corner up here. Yeah. And then here... Where's the macro to, like, just clean stuff up? Refill. Okay, cool, yeah. Oh, that seemed to have erased that, though. Maybe I didn't link that up the way that I thought I did. Okay, that should be connected now. Which means we just have this stuff up here, plus whatever this missing one here was. I guess we're gonna have to... What was the expand button again? Was it E or was it D? That was U. Oop. Okay, I want all those to be unbroken because it's elegant. And then you can just have those ones go subterranean. Oh. Okay. This one's isolated somehow? Why aren't you connected to anything? That's strange. Oh, it's because that one's... We didn't actually route that one anywhere. Okay, well that's easy to fix. And then you should have a lot less disconnects now. Unconnected items, just 13. Alright. Let's just start linking up all those ones and see if we can just get away with some messy-ish routing. Alright, and that should probably leave, I think, only 4 unconnected now. 5 unconnected. Pretty close. For this, we're probably just going to want to do some underground traces. And then what's the one last unconnected item then? Okay, just this one. Okay, cool. Everything's connected, I think. Yay, everything's connected. And so I think the only issues we have now are just overlapping courtyards, which there's 12 violations. That is one for each key switch, which is exactly what we expect because we're overlapping the RGB LEDs with the key switch footprint, but we're not assembling the key switch at the same time, so they shouldn't get pissed, and this really does actually overlap, so I think it actually works. Alright. Oh, I like to put ground planes just on the tops and bottoms anyway, because it makes things look nicer for some reason, I guess. So I'll just do that. Okay. Ground plane. Okay. And another ground plane. Oh, this should go on this one. Okay, and then let's see what that looks like. Woohoo! Cool. That's not too bad. Probably space things out to be a bit neater, but this should work. Yeah. Alright, well, I think that I want to wrap this up today. Feeling a little bit tired, so yeah, I'm gonna go call that a stream. I guess next stream is gonna be on Sunday afternoon, and we're gonna keep iterating on the hydrate, on the forced hydration machine. But yeah, we did some PCB design stuff. That's fun. Let's switch to the office view. I don't know why my mocap trackers won't turn back on, but it's okay. This is funny. Well, anyway, yeah, I guess that's today's stream. Did some PCB design, and I'm gonna go log off, yeah. Alright, logging off, bye-bye.